Hello to Dr. Harris. We are from Group 21. We're going to present our group assignment. The introduction for our group assignment is this assignment aims to deepen understanding about electrical engineering concepts like circuit analysis and signal properties using multiple multism software for practical simulation. It enhances analytical skills by applying theory of real-life scenarios and promote teamwork through group problem solving and communication. Key topics include volume controls, RMS versus peak voltage, and so on. So, in this assignment, we will explain detailedly one by one.
Good morning, sir. My name is Savitam Rajendran. So I will answer the first question. When an electrical signal is converted to sound by a speaker, the loudness of the sound depends on the amplitude of the signal applied to the speaker. Based on this, explain how the volume control potentiometer is used to adjust the loudness volume of the sound. A volume control potentiometer is a variable resistor that regulates the amplitude of the electrical signal reaching the speaker. When you turn the knob of the potentiometer, it adjusts the resistance in the circuit. This change in resistance controls how much of the electrical signal is allowed to pass through. Higher signal amplitude, louder sound. When the resistance is low, more of the electrical signal is allowed to pass through to the speaker. This increases the amplitude of the signal, producing louder sound. Lower signal amplitude, softer sound. When the resistance is high, less of the electrical signal passes through. This decreases the amplitude of the signal, resulting in softer sound. By varying the resistance, the potentiometer effectively controls the electrical energy sent to the speaker, which determines the loudness of the sound it produces. That's all from me. Thank you.
Assalamualaikum Dr. Haris. I will continue with the question number 2. And the question is explain with suitable diagram why RMS voltage is not same as peak voltage. At first, I will define the definition of RMS voltage and the peak voltage. RMS voltage is the equivalent DC voltage that will deliver the same power in a given resistance as that delivered by the AC voltage. It gives the effective value of AC voltage. In sinusoidal wave, the RMS value is lower than the peak value. Peak voltage is the maximum value of voltage in a sinusoidal wave. It is the height that the voltage reaches at its highest point in a single cycle. It is many times referred to as amplitude. This is VRMS formula. This formula explains how to calculate the RMS voltage from the peak voltage in an AC or alternating current circuit. This diagram illustrates that the RMS voltage is less than the peak voltage, which is understandable because it takes the average of the square values of the waveform to get its root for the RMS value. It takes the peak value by the maximum voltage reached within the waveform. As you can see in the slide, the green dashed lines show the peak voltage or V peak, which is the maximum positive and negative values the waveform reach. And then the red dot line gives the value of VRMS about 0.707 times the peak voltage for a sinusoidal waveform.
I will continue with question number 3. With suitable description, explain the controversial issue of Bakun Dam in Sarawak. The first thing that we will discuss here is about environmental impact. There is three environmental impacts that we stated for Sarawak Dam, which is deforestation and habitat loss. This resulted in a destruction of habitats for numerous plant and animal species, some of which are endemic of the region. Secondly, greenhouse gas emission, the decomposition of flooded station releases large amount of methane and potent greenhouse gas, which will lead to huge pollution for the environment. Thirdly is about water quality and sedimentation. The dam has altered the natural flow of the Balui River, which leading to giving an impact for people who live around the river area. The second impact of the dam is social impact. It has two different impact. First of all is displacement of indigenous communities because around 10,000 indigenous people from various ethnic groups including Kenya, Kenyan and Penan was displaced because of the dam's issues, so they have to move to another place. Second one is culture dispersion. Many struggle to adapt to new agriculture practice and face economic hardship. This is because when they have to move to another new place, they have the difficulty to adapt to the new place. The third impact of Sarawak Dam is economic and legal issues. We have three varieties issues that we can state here. First of all is cost overruns and financial viability. This is because the project initially estimated to cost around 50 million. But it faced significant cost overrun, which means they have to put some more cost in solving these issues. Secondly is transparency and governance. The environment impact assessment on EIAs were fragmented and not fully disclosed to the public, leading to legal challenges. Third one is jurisdictional conflict where there were conflict between federal and state indication about the environmental issues and pollution around the Sarawak Bakun Dam.
Hello, my name is Fatina Atira binti Mazim and I'm the presenter of question number 4, which is determine the half cycle average values of the voltage across R1 and R2 in figure 1. All values shown in RMS, proving using multism software. So for the first one, we need to determine voltage across the R1. So the voltage must be determined first for uh, to calculate the average R1 and R2 voltage. So we use the formula of Vs minus R4, which is for the first step, Vrms1 equal to Vs minus Vr4. So we get the value is 55 volt. And for the step 2, we must adjust it to the normal voltage, even though we know that Vrms1 is 55 volt. So we use the formula of Vrms equal to Vp over square root of 2. But since we don't have the Vpeak, so we rearrange the formula like Vr1 equal Vrms1 times square root of 2, and we got 77.782 volts. And for the last step, to find out the V average one, so we must apply the formula, which is V average one equal to 2 VR1 over pi, and we got 49.517 volts for V average one. Alright, next we want to determine the voltage across R2. So for calculation of voltage across R2, we use another method, which is mesh analysis. For step 1, VR4 minus VRMS2 minus VRMS3 equals 0. And for the last, we got that VRMS2 equal to 35 volts. Okay, then for the step 2, we know that the VRMS2 equal to 35 volts. We need to change the value into the normal voltage. So thus we use the formula of VRMS equal Vpeak over square root of 2. Because we do not have the value of Vpeak, so we rearrange the formula like before, VR2 equal to VRMS2 times square root of 2, and we got VR2 equal 49.497 volts. And the last step, we use the formula to determine the V average 2, which is V average 2 equal to 2 VR2 over pi, and we got 31.511 volt. So last but not least, we determine the value of RT, R3 and R4 by using the mesh analysis. Since the value we got is voltage roots mean square, VRMS, therefore we need to adjust. Thus, every formulation will multiply by square root of 2 to make it become a normal voltage. So as you can see, we have two equations for step 1, equation 1 and equation 2. And for the next second step, we got to find the value of I1 and I2. So we solve the simultaneous equations by adding the equation 1 and equation 2. So we got I1 equal to 0.165 ampere, and I2 we got 0.116 ampere. Since I1 is the total current, the total value of I2 and I3 will equal to I1. So we got I3 as 0.049 ampere. And last step, step 3, so we know that V equal IR. So to find out the value of R, we will rearrange the equation into V over I. That square root of 2 stand for the change from VRMS to normal voltage. So we got that R3 equal to 865.845 ohm, and R4 equal to 792.447 ohm. So this is the results. For the first one is the proof of VRMS1 equal to 55 volt, and the second one is the proof of VRMS2 equal to 3.9 volt, which is 35 volt.
Hi, I will discuss about question number 5, which the question is sine wave. Firstly, we need to identify what are the parameters given in the questions, and it's already given that the RMS value of the sine wave VRMS equal to 10.6 volt and the DC level reading equal to 24 volts. After that, we can find the relationship between the RMS and peak value by substituting the VRMS 10.6 volt into the equation of V peak equal to VRMS times 2, and we will get the reading for V peak equal to 14.991 volt. After that, we can add in the DC offset to find the maximum value of the waveform and also the minimum value of the waveform. For the maximum, the formula is V maximum equal to DC level plus V peak, and for the minimum is V minimum equal to DC level minus V peak. For the V maximum, we just after substituting the value of V peak, we will get the value for V maximum equal to 38.991 volt, and for the V minimum we will get the value of 9.009 volt. To prove the theoretical reading, I need to enter the VRMS value and the DC level current into the multisim software, and to be conclude that the maximum value from the oscilloscope, which is 38.736 volt, closely matches the theoretical value of 38.991 volt, with a slight difference in reading due to the error in measurement or maybe because of signal noise. Meanwhile, the minimum value from the oscilloscope reading, which is 9.178 volt, are closely aligned with the theoretical value that being solved, which is 9.009 volt, with a small variation attributable to the same factors. To be conclude that the waveform conforms to the expected parameters, demonstrating that the theoretical calculations and the oscilloscope readings are both inconsistent.
In conclusion, the assignment presented an opportunity to unravel some of the foundational principles of electricity through theoretical calculations and practical validation using multisome. Analysis of half-cycle average voltage across resistors emphasized the vital nature of knowing signal characteristics vis-a-vis the impact on circuit behavior. The assignment had shown the importance of group effort as well as collaboration in teamwork by solving some complex engineering problem. Thank you.